Hello everyone, we will solve this today's LeetCode problem. This is again LeetCode hard. This is word break 2 problem. So let's see what it is. So here we have given a string s and a dictionary of a string's word dict. Add spaces in s to construct a sentence where each word is a valid dictionary word. Return all such possible sentences in any order. Okay, so we have given a string and we have given a dictionaries of words, right? And we need to split this string such a way that each and every string should be a part of this dictionary of words, right? So what does it mean? It means here that if you see in cats and dogs, so you need to uh, put a space between this string s. Suppose this is cat, so if I put a space after this cat and then it becomes a sand dog, right? So this cat is in my dictionary of words. It means this is a valid partition, right? After this sand, after this, if I put a space a partition here, sand, this sand is not exist in this dictionary of words. So I can't do a partition here. So can I do it here? Yes, I can do it here because this sand is already exist in my dictionary of words, right? And this dog is also exist in my dictionary of words. So we need to partition this string such that each and every word each and every word should have must have must have in must be present in dictionary of words, right? Dictionary of words. So this is the question. So if you have solved uh, if you solve palindrome partitioning, if you have solved palindrome partitioning problem, I think that was comes in Litco today. Litco's problem, I think 3 4 days back. Partitioning problem. This is something similar. This is the same as similar. So if you have done this, you should be able to do that, right? If you don't, we will continue it, right? So this is the same as palindrome partitioning problem. So if you see here, what we need to do, we need to partition at each and every position and see that which words are present in my dictionary of words, and then only I can form a sentences, right? So if you see its time complexity, it's 20, right? So it means for partition for partitioning at each and every index, for trying to partition it at each and every index, partition at each and every index, partition, right? As in index, I have two choices, right? Either I can either I part either I part either I do a partition or left it. I have two choices for each and every disk, huh? So either I will do a partition or I will left it. So I have 2 to the power n choice, 2 to the power n total that I need to check. So if you see it to the 20, it's it's a valid time of complexity that we can use, right? So it's only 2 by 20, so it's a valid partition. So I can use recursion, of course, right? So I need to check each and every possibility for this string to get partition simply, right? So for that we know that we need to use a recursion for trying all possibilities. For trying all possibilities, I need to use a recursion definitely, right? I need to use it definitely. Whenever you try to find all possibilities, you need to implement recursion anyhow. So let's see how we will implement recursion. So if you not solve this problem, I will definitely tell you to solve this. Then comes to this, you will definitely able to solve this by your own, right? So let's start from the first example, which is given cats and dogs. It's the same recursion tree which we are making from the last 3 to 4 times, right? Last 3 4 days. So if you see, this is a cats and dog, right? This is cats and dog, right? So if if I try to, if I try to start from zeroth part, what will I do? The first thing, I can do a partition here or not, right? So first thing is starting from zero. What I need to return this cats and dog. So what is this? This is a string, and this is a vector of a string. It means I need to also maintain a string which is valid, right? So I will maintain a string. I will maintain a string. So this is s, and this is a word dict, right? This is a word dict. So I will check for each and every partition that whether this word after partition exists in my dictionaries or not. So what I will do, I will start from zero. I will move with that empty, because starting position is empty, right? And then we will start, right? The first thing, I again have two choices. What is the choice? That I will partition at zero or not, right? I will partition at zero or not. So the first thing is, this C should be included. If I include this C, if I include this C, I will check whether this C present in my word background. It's not present, right? So I need to again check for A. So CA, right? CA is present. No, it's not present. Again, T is present after adding this cat. Yes, cat is present here. Cat is present in my dictionary of words. I can take this cat with my strings, right? So if I can take this cat with my strings, it means after this cat, this is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, right? So after this cat, what's the index? It is 3 index. It means after this 0, I can partition this. After this cat, I can put a partition that will become cat, right? And how, what's the index would be now? It will be 3. So from 0 to 3, I get a cat. Before 3, I am not able to make any word which is exist in my word dictionaries, right? So from 0 to 3, I made a cat and insert in my string, right? Now if you see here, this after every word I need to put a string, I need to put a space between them, right? So it's just an implementation part. How will you handle that, right? So if after I get a word, I will insert a space between it, so that will again give me a space, right? Now after this 3, after this 3, what I will take, I will have again both of the choices, right? I can put a partition between s after this s. So if I put a partition after s, whether what will I get? I will get cat s. This will I get, but this s is not not in my dictionary of words. So can I partition it? No, I will. I'm not able to partition it. So again, I will check for sa. Sa is also not present. SA N also is not present, but SA and D is present. SA and D is present, which is at sixth position. It means after this sand should be included with my cat and sand, and there will be an space also after this, because for each and every word I need a space after that, right? And this index will be after 6, which is 7, right? So this will be the string form after this. Now again, now again, what are the choices? What are the choices? So if you see here, after the 7, cat and sand, this from starting from the 7. Again, I will do the same thing. I will check for cat and sand. Does D is exist? No. O is exist? No. G exist? Yes. Dog is exist. So I will add this, and also an extra space from here, right? An extra space from here. So if you see, either I can put a space at starting, at last, or I can put a space at starting, because this is empty string, and whenever I get a word, I will put a space and then tag. So whenever I get a word, I will put a space then sand, and whenever I get a word, I will put a space then dog. So if you see, at last, what will I get after this dog? This will be 10, and we have a space then cat space sand space dog, right? So if you see in this 10, if you see in this 10, this is the last of the strings. It means I have completed my string, and I got a some word. This is the last point. This is the last point. I need to return it from here. Something got written now, because this is the last point. I also confirm that I will get a sentence which all words exist in my dictionaries, right? So I will just store this, but what? Here you see that the first position, this is there is just one extra space here, so I need to remove it anyhow, which we will see in implementation part, right? How we can remove, right? So this after excluding this space, I need to insert this cat, sand and dog with me in my answer. So I got one answer, which is this: cat, sand and dog, right? This is the first word I am getting after this. And what's the base case? When we got on the last length of strings, then we will return it. And one thing more, when we are returning this, what we return? Nothing. We just backtrack this. So why we need to backtrack this? Because this dog is inserted at the 10th position. Before this is only a cat sign, not dog, right? So I need to backtrack this to make a cat sign, right? Right. Because why need to backtrack? Because if you don't backtrack, how will you check the further possibilities? Suppose because you need to check each and every possibilities now, after D separation, after O separation, after G separation. So you just need to backtrack this to maintain this, to get the to try to all possibilities which we you can get, right? After the 7, you will again backtrack this to cat. This sand need to be removed. After this cat, you need to again backtrack this, right? So if you backtrack this will become again empty. Now this 3 and this cat, this should be again check that this after this cat, what will be the possibilities? We can make cats, right? As can be also included. So if you see cats already also exist, so I got another word, right? And the index would be, this is cats is at 3, so I will start from 4 now. Now after this 4, let me give some spaces. After this 4, what are the again possibilities? So I will not making uh, all the branches here, because that will be again more complex. You can if you want to try all the possibilities, you can see this question just 3 4 days ago, right? I will ping this. So this is 4 and cats. So after this cats, we will start from 4. So this A exists? No. What can be the possibilities? Cats is okay. This is space and cats, right? So cats and space and then S. So is so this A exists? No. This N exists? No. This D exists? Yes, and is exist. And is exist in my word dictionary. So cats and can be included. And what will be the iteration? So after this and, of course, that is 7. So this is the cats and 7. Again, so these possibilities, the possibilities which I am trying to solve, it is just seeing that, checking that whether the word is exist or not. What does it mean? It means that this cats, this cats and the possibilities A. Again, one possibilities is uh, cats. And so this cannot be included now, because and is not a part of the scenario. So this will be left out. There will be no any branches. So I am just considering only those which will be in my further part, recursion part, right? So is this, that's why I'm not including these are, this should be included in my siblings, but I'm not including right now, right? So now after this cats and. So after and, what will the next iteration? That is 7, right? That is really 7. So after the 7, what will I see? I will check. I will check again that this cats, this cats and and. Now this dog. D exists? No. O exists? No. Do not exist? G exists? Yes. Dog exists. So I got another string with a space, and this is the last position, which is 10, right? This is the last position because I have started from 7 and go to the its next iteration, that is 10, which is the last. So I will get a another sentences which will I store in my answer, that is cats and dog. So that will I store in my answer, right? Simply, this is a vector of a string. Answer is a vector of a string, array of a string. Okay. So I will just return here. So again I need to backtrack this to make cats and dog same as cats, and again I need to backtrack this cats and to make cats, and again cats will be the same. Now if you check after this, if you check the same thing, what I will check, I will check for each and every possibilities again. I will check for each and every possibilities again. So for that, what I will do, I need to check that is cats a exist? No, it's not exist. I will not move further. Cats and exist? No. Cats and exist? No. So if you see, there can be no possibilities that if I include the characters at last, there will be no dictionaries of words which exist here. So I will not move further. So ultimately, I will get two only sentences, that is cats, sand dog, and cats and dog. So this is the pure question of recursion and backtracking, right? Recursion plus backtracking question. That's the same problem as a palindrome partitioning or yesterday's problem. That's the same concept, right? Right. I need to make a same concept here. So what I'm doing, I am trying all possibilities. I'm trying all possibilities. So if you want to see all the uh, whole recursion tree, you can watch this palindrome partitioning or yesterday's problem. So that's I have made all the recursion trees in all, right? So I am trying to trying all possibilities for partitioning, right? Of course, for partitioning I'm trying all possibilities, and whenever I partition, what I'm checking I'm checking that the word which is formed the word which formed is exist in my word dictionaries, which is given, right? Which is given, right? If it is exist, I will. If it exists, there can be possibilities that there can be there may be a possibility there may be a possibility that I will get a sentence right? So this is we will do. Let's see the implementation part. You will understand it better, right? So if you see here what I'm doing, so this word dictionaries need to be checked. So if for checking here, what we do for checking, if you iterate in whole words and check one by one, that will take, of course, o of n into m. N is the dictionary length of word, this word dictionaries, and m is the maximum length of any word. So for checking what we use we will use a hash map for storing all the strings present in word dictionaries, right? For checking the word after partitioning from a string, after partitioning from a string, because in hash map, for checking, that takes o of 1 only, right? So I don't need to iterate for checking every time to whole dictionaries, right? After partitioning, right, of s, right? So this will we do, right? This will we do. Okay. And also I'm maintaining a string, a temp string to push the characters, and at last I need also a vector of a string to return the answer, right? So let's see, we have analyzed all the concepts. Let's see what we do. So here first thing is I need to take an unordered map, right? To So I will make it a globally, that will store my strings of all the strings of word dictionary. Let's take it as a map. So I will iterate. This is a word. Right. So what we'll do, I will store all the words in my hash map. First thing. Okay, the first part is completed. Now I need to try all possibilities. So I need to call a solve function. The first thing is index, then temporary strings, right? So I will pass 0. I will pass also this string s, because the main thing is that, and also an empty strings, which would be temp. temp. So I will pass these three things, right? Also I need to store this temp in my answer. So that would be an string which will be finally returned from here. Suppose this will give me an answer, finally I will return this answer, right? Now the main part is trying all possibilities. What we will do, we will start from this index, this string s, and this is a temp. Why we are passing by reference? Because you know that if I pass by value, it will create another copy, and that will take again extra time and space conflict both, right? So now this s size should be there. The first thing is what we do, we are checking for each and every possibilities. So we started from 0. We start checking to include every characters from this s, like c, then a, then t. And whenever I get a word from this word of dictionaries match, I am going again call this solve function after this 0 part. It means this second part, the cat is at 2 part, this is the cat is at second index. So I will call another after this, that is I plus 1, that is 3. So the same thing I will do. How we will iterate? I will start from I part, then I will move to n part and j plus plus. Now now what I will do, I will take okay, what I will do, I will start taking I will start make a previous. Why? Because I need to also backtrack to this. So I need to start whenever I include any word in my temp string, I need to, when I will try to backtrack, I need to make this cats and not cats and dog. So I will, what I will do, I will store this temp which was before in my previous. Now what I will do, I will just check that after this iteration, them dot pushback, right? So let's make a string s also, a string s. So this is a temporary strings, which what is the need of this? I will push back this sj, right? And I will check whether this mp, this substring exists in my count or not. If it exists, what I will do, I will just call after this iteration this ss, this ss dot pushback sj. And after this string exists in my map, it means I need to call after this iteration. So what I will just call, I will call j plus 1. This s would be there, and the main thing, this would be ss, because this temp stores the whole string. So I need to add this word with me. But I told you that if you see that there is a space between words. So what we are doing, we are giving spaces at a starting point. But I told you that we got an extra space at the starting point, because if I do like this, temp plus ss, temp plus ss, so it will give me an extra space at the starting position, right? Right. So for that, I need to check the first thing, that if my temp is not empty, then only I will give a space. So if my temp is empty, so if my temp was empty, so if I give a empty string, that will give an extra space to the sentence. So if my temp is not empty, it means I have a word in temp, then only I will give a space between them, right? And after that, I will just include temp plus ss and pass it to this temp, right? Now when this solve function when this solve function give us oh sorry when this solve function give me my answer. I think I have written wrong place. This should be here. This should be here. Right? This should be here, right? So after this, uh, again wrong at wrong place. This should be here, right? Yeah. So whenever I get a word, I will check whether this my temp value is empty or not. If it is not empty, I will put a space between them and add this word with my temp, right? And pass it on. So this temp has my word. Now when this solve function solve function get returned, after this I need to backtrack this. I've just told you that when this get returned, I need to make this cat sound same as before. So that's why I have stored this previous temp to make this as previously. So what I will do, I will just initialize it with previous to backtrack this, right? I will just initialize with it simply. Now when this recursion will end, I told you that if my index is at the out of bound of size, so what I need to do, I will definitely show that this temp will give me an sentence. So I will push it in my answer, which is vector of a string answer, and return it for me. That's it. That's give me the correct answer, right? So main part is this. This is the main part. What I'm doing, I'm checking all the possibilities from I to make a word. So I'm just taking an extra word and inserting characters sj in my temporary strings and checking that whether after every insertion I am checking that this string exists in my word dictionaries or not. If it exists, I am adding this to my temp string to make this word as a sentence. For each and word addition, we need a space between them. So if I need to check that whether I have already exist a word in my temp or not. So if it is not empty, I will just include a space between them. Otherwise it will give me an extra space in my sentences, either at the first part and or the last part, based on your implementation, right? And after this I will just call the one part again of j plus 1 and call this temp again. Now when this solve function returns, I need to backtrack this. That's why I stored this previous at my temp, and I will backtracking from here. So why backtracking? Because this cats and dog comes after the insertion of dog, but before that, that is cat and sand only. So I need to make this to try all the possibilities from here part, right? So that's how we will solve this problem. And after this, I have just stored this temp in my answer whenever I get a base case. So this is how we will solve the question. Let's run this. I hope I have not done any compilation error. Yeah, I have done any compilation error. What is it? Yeah, this should be colon. Let's see. I have not done any compilation error. Run it. Again, I have done something wrong. Okay, this temp is not declared. Let's declare it. We have passed the sample case. Let's submit it. Yeah, we passed successfully, right? Now what the time and space complexity, I think you must have known till now what will it. So we have two options. Either I partition at each and every position. So for each and every position I have two options. That will be definitely 2 to the power n, where n is length of string, right? Also uh, also I have stored this word dictionaries in my map, so that also take o of m. So it will also take o of m for iteration. So that will be o of m. So what is m here? M is length of word dictionaries which is given. Word dictionary, right? So this is the time complexity, and what will the space complexity? So the space complexity will be would be now for each and every possibilities. I am checking that what would be the answer, right? What would be the answer? So for each and every possibilities I am checking. So for each word I have two options, right? So for each word I am I am taking an extra I'm going recursion again. So dogs the recursion stack space would be on 2 to the power n, of course, right? Because I'm going for each word two times for because one times whether we are partitioning or other we are whether we are not partitioning, so that will be 2 to the power n. And the second, we are using a map to store these words, right? So that will be again O of m will be the length of word dictionaries, and this L would be the max length of any word present in this word dictionary, right? So overall, if you see, this will be O of 2n to the power n, and because here if you see constants, they are not much of bigger length, so that will not much get much effect. This will be also overall a O of 2f1. So if you solve by any algorithm, either recursion plus backtracking or anything, you need to try all possibilities, and that will be give us O of 2 to the power n time complexity, and the space complexity would be O of 2 to the power n. Either you try to uh, optimize it in much more further. Is it your hand? Because we can optimize it more further, but ultimately the time and the space complexity would be this only, right? So this is the similar approach. uh, yeah, this should be the answer. Hope you hope this helps. Thank you. Bye bye.